Thank you all, and good afternoon. So I'm going to talk about the Copernicus Marine Shell service, a short overview of this service, the modeling, the ocean modeling associated to this activities to these services, and the link with EDITO, the digital European Digital Twin Ocean, and the link with Iliad project. So Copernicus is an Earth observation program of European Union. It's composed by 6 components for land, for atmosphere, for climate change, for security, and for emergency, and for marine. And the Copernicus Marine Service is funded by European Commission and implemented by Mercator Ocean. And it consists in a web portal which provides free, regular, systematic information on the state of ocean. We can divide ocean in 3 colors, 3 domains, in fact: blue ocean for physics, white ocean for sea ice, green ocean for bio. So you can find the products of these different color ocean in the web portal of Copernicus Marine Service. We can divide the ocean in different areas: global ocean, the Arctic Ocean, and the European regional seas. And for each areas, different organism, private organism or public organism in Europe organized in consortium in order to develop monitoring system and forecasting systems in these different areas. The different numerical models are assimilated with data observations, and they reach horizontal resolution from 10 kilometers to 1 kilometers. It depends on the areas you consider, and the vertical resolution from 1 meter in the surface to 500 meters at the bottom. And we consider products, model products in the past with the multi-year products, and in the future with the forecast products. For the forecast products, they come from the result of the ocean model, deterministic ocean model. But we expect in the future for this service to provide also products from ensemble systems, stochastic systems too, but in the far in the future, of course. It's not ready now. The forecast follow daily cycle, and the forecast leads in 10 days. Regarding multi-years, products, they extended from 1992 to 1 or 2 years before present. New time series are provided every 3 or 5 years, and the time series are regularly extended. Regarding the blue ocean for physics, user can find in the web portal the temperature variables, salinity, currents, sea level, mixed layer depths, and waves. For the green ocean, user can find nekton data, plankton, organic carbon, nutrients, oxygen, carbonate system, and optics such as ocean colors. And for white ocean, users can find sea ice concentration, sea ice extent, sea ice thickness, sea ice type, sea ice velocity, snow thickness, sea ice albedo, and sea ice age. All these products are rigorously assessed. Each new products or updated product are assessed, of course, and even during the operational providing, there is a monitoring of in a real time of each products. Regarding the different products for forecasts, there are 23 products for blue ocean, 4 products for white ocean, and 7 products for green ocean. And regarding the multi-year products, there are 12 products for blue ocean for physics, 4 products for sea ice, and 6 products for bio. The number of users is steadily increasing every year since the beginning of the Copernicus service. And forecast product has a slightly higher number of users than multi-years one. We can reach in totally about 20,000 users in 2022. Yes, there are, in fact, for each areas, each consortium that I presented before, which who developed different models for the forecast products, use different models for bio, for ice, for wave, and for physics. And for each area, there are different models too for these different components. And these models are connected by a coupling method or forcing method. But finally, even if there are a strong diversity of models, you can converge to the standard products, which follow the same format, file format, the same metadata, the same standard name for variable, and so on. And the Copernicus service brings about a lot of downstream services with a strong link with the coastal application. And you can see in the website of the Copernicus Marine Service a lot of examples of the use cases. For instance, regarding the harbor safety, the ensemble multi-model has been developed for sea level forecast at the Spanish harbors. So we consider many models in the overlap zone, and we can provide a kind of ensemble forecasting. And this ensemble forecasting provide better forecast than any individual members. So, and another use case is the sargassum, monitoring of the sargassum drift and beaching monitoring in seasonal forecast system. You can find this kind of system in the 4C project website, which provide monthly sargassum drift in the equatorial Atlantic. And sorry, I answer to the question. And this model, there are 2 components in this kind of forecasting model: physics and sargassum model, evolution model. The physics model is forced by Copernicus Global Ocean Forecasting System, and the sargassum detection is initialized by MODIS satellite remote sensor data. And soon it will be replaced by, probably replaced by new data from Copernicus of detection of sargassum. Up to now, the system is operated in best efforts, but we plan to make fully operational this system. And it will be a demonstrator, use case demonstrator for the future edito. So to conclude, Copernicus Marine Service is a complex and mature system since 2015 with a continuous evolution. And we expected an increase in resolution. We expect to provide ensemble forecast with uncertainties associated. And we plan to improve the link with the European coastal forecasting system for downstream services. And so finally, Copernicus Marine Service is one of the cornerstones for EDITO, for the European Digital Twin of the Ocean. where the downstream services developed in the framework of the Iliad project, for instance, will be plugged in to this cloud platform. Okay, I finished. Thank you.